Okay, let's do some examples for the derivative of parametric equations. So parametric equations, a set of parametric equations given. Now we have two questions. One is about tangent line and one about, or both of them are about tangent line. One is finding tangent line, the other one is finding points at which the tangent line is horizontal or vertical. Okay, so here for both cases we need dy dx. And by the fact that we learned before, we know that for the parametric equations, to find dy dx, we need to differentiate y with respect to t. Here it means that 3t squared minus 3, and divided by the derivative of x with respect to t. This is 2t. Okay. Then we want to apply it. Let's say do part 1. Says that show that there are two tangent lines to the curve at the point 3, 0. Well, one thing that you have to know is that in this method, the derivative is given in terms of t. And now, if you want to evaluate it at some point, you have to translate it in terms of t. So find what are the values of t for which the curve passes through 3 and 0. So that is the first thing. For what values of t the curve passes 3, 0. Well, passing through the point 3, 0, it means that x is 3 and y is 0. Well, since I have equation for parametric equation for x, I can replace it, and that means that t must be root 3 to make x 3. Then you solve it and you see that for t being either root 3 or negative root 3, we get that point. Now, note that y at root 3, it must be 0 as well. Otherwise, this doesn't work. We need both x to be equal to 3 and y equal to 0. Let's plug it in. So root 3 to the power 3 minus 3 times root 3. This is, well, yes, this is root 27 minus, well, I can take 3 inside the root, but you have to square it, so it will be root of 9 times 27, 9 times 3, which is 27, and that will give me 0. So that means that, yes, root 3 will make y 0 as well. And what about root negative 3? That will give us the answer here as well. This case, you will get negative root 27 minus, plus root 27, which will give us 0. Here, there's something important. If you set y equal to 0, other than root 3 and negative root 3, there is another t equal to 0 as well. But we are not interested in that because t equal to 0 doesn't make x 3. So that's why we will just ignore it. What does this mean? This means that whatever the curve is, it will go, well, I don't know how it will work, how the graph is, but when you sketch it, you'll notice that, okay, at this point, which is 3 and 0, the graph will, actually more probably it will be something like this. So that means that the parametric curve will pass that point twice. So it will basically intercept itself. So that means that if you consider for one t, you will have this tangent line, and for another t, you will find that tangent line. We will see at the end of this computation which one gives us the which one. Okay, so now we have the point. Now we want to find the slopes. For the point was 3, 0 and t root 3, then slope is going to be dy dx at t equal to root 3, which means that 3 times root 3 to the power 2 minus 3 divided by 2 times root 3. This is 9 times 3, 20, so root 9, which is 3 times 3 is 9 minus 3, which is 6 over 2 root 3, and then you simplify 3 root 3. Okay, you can simplify further and you get to root 3. So one of these guys is going to give us a positive. So that most probably this is going to be that one. And this is just coincidence that the slope is exactly equal to the value of the t at that point. This is just coincidence. Well, if I have the slope and I have the point, then y minus y0 equals to m times x minus x0. That means that y minus 0 equals to root 3 times x minus 3. And that means that one of the equations is given by y equal to root 3x minus 3 root 3. How about the other point? So, well, the same point, but different parameter. If you plug it into the derivative, this is going to be 3 times negative root 3 squared minus 3 and 2 times negative root 3. That is 6 divided by negative 2 root 3, and this is 3 over negative root 3, and this is negative root 3. So for that point, that value of t, the slope is negative, and that's why you will see that this is basically when t is negative 3. Okay, and then the equation for that, y minus y0 times m x minus x0. x0 and y0 are the same points or the same numbers, but the m, the slope is different. Okay, so that finishes part 1, but there's another part as well. It says find the points at which the horizontal, the tangent line is horizontal or vertical. Okay, so horizontal means horizontal tangent means that dy dx is equal to 0. In other words, 3t squared minus 3 over 2t is going to be equal to 0. That implies that the numerator must be equal to 0. And that implies that t squared is 1. And this means t is either plus 1 or minus 1. So for t equal to 1, the x component, okay, let me check that. T2 is going to be 1 and 1 squared. Let me write it like that. And the second component, t cubed, which is 1 to the power 3 minus 3 times 1. And that is 1 negative 2. Okay. And for t equal to negative 1, this is going to be negative 1 squared, negative 1 to the power 3. This is 1, and then that is 2. So we have 2 points at which the tangent line is horizontal. Okay, And there's another, the vertical one. This is basically when the slope is not defined, or dy dx specifically is infinity, plus or minus infinity. Well, here I specifically mean that limit that defines the derivative gives us plus minus. But if you look at the derivative there, this is a good function, and it doesn't get it gets all, for every number it gets good number, unless you have the denominator 0. So at 2t equal to 0, it is not defined. And you see that at that point the dy dx either will go to the plus infinity or minus infinity. Yes, and that's the key point for us, because that means that if I set 2t equal to 0, which means that t equal to 0, this will give me the point at which the tangent line is vertical. So if you plug in t equal to 0, this is 0 squared and 0 cubed minus 3 times 0. This is 0 and 0. Well, having all this information, maybe I can now try to see if I can sketch the graph, or what I had before makes sense or not. Okay, so this guy is going to pass at least from these 4 points. 0, 0, and at that point the tangent line is vertical. 1, negative 2, so 1, 2, and 1, negative 2. So at these points the tangent line is horizontal. And at 3, 0, which is somewhere there, the tangent line, there are 2 tangent lines. One like that, the other one is like that. There are a few more observations. For example, t squared, x is t squared, so it means that we are going to have only non-negative values of x. So if you then go, you notice that, okay, so t comes like that, goes down, goes up, like alpha there. And the direction, actually, the way it works, you see, for this guy, t that we found is -1. For this guy, we have 2 values of t. T is -√3, or t is plus √3. And for this guy here, t is 1. And for this one, t is actually 0. And that kind of gives you the direction at which this curve is parametrized. Yes, so this will start going this way, go down, and then go up. Okay, that's just an application of how you use the derivative of parametric equations to find different information about the curve.